When you're looking at ANOVA, we're basically looking at analysis of variance. So analysis of variance is a statistical method that we use when we're comparing 3 means and above. So when you're dealing with 1 or 2 means, we're dealing with Z or T. But ANOVA allows us to determine whether there is a significant difference between more than 2 groups. And so ANOVA has the following assumptions. Number 1, the assumptions are that the observations within each group or treatment are independent. So independence. These characteristics are important because you'll be asked, first of all, to establish the assumptions under which ANOVA is established. So this means that the values of each group should be treated as independent. They should not influence the other. The second assumption is the normality, that the data within the group should follow a normal distribution. So in ANOVA, it is always normally distributed. Then also homogeneity of variances. So here the variances are compared to be equal. And this assumption implies that the spread of the data in each group is almost roughly the same. And finally, the groups are mutually exclusive, meaning that each observation should only belong to one group or treatment, and there should be no overlap. That is the assumption under ANOVA. So these assumptions, you must note that violation of any of them can affect validity and viability of ANOVA. So in these cases, the alternative tests of the data may be considered. It is also important to assess these assumptions before applying an ANOVA or analysis of testing on sample groups. So ANOVA table has a format that is as follows. So ANOVA table, can somebody give me the format? How's the format for the ANOVA table?
Treatment, error, and total.
So ANOVA has the following variations. We have the treatment, which we call between. We have the error, which we call within. And we have the total under the ANOVA. So it is very easy to balance up an ANOVA table. So once I teach you how to balance up an ANOVA table, you'll be able to get your 15 marks completely. So to start with, we can simplify the populations to be treatments or columns. So we can have treatment 1, treatment 2, treatment 3, treatment 4. These ones are called populations. They're denoted by the letter K. How many treatments we have? We have 4. Observations are the number of elements inside here. So here we have 5, 6, 7, 8, 9, 10. So this is 12. The number of observations is denoted by the letter N. So how many observations we have? We have about 12 observations.
Of
Are we together? So suppose you are given your sum of square total and your sum of square between. So maybe you're given a 30 as your sum of square between. Then we have 190 as sum of square total. So let me teach you how to balance up the Anova table. By now you should have this format. So remember the format for the Anova table. Who remembers? I'm just from giving the Anova table format. Are you seeing any lines on the screen? The black lines?
No, it's just
Clear.
it's okay. It's clear.
So the sum of square total we've been given as what? 190. The sum of square between we've been given as what? 30. And our K is 4. And our N is what? 12. So let's balance up this. So this column here we're going to have is called the sum of square between. So between here we have 30. Total, we've been given 190. The difference, sum of square between, sum of square total. When we subtract them, we get sum of square within. So 90 minus 30, we get 160. Then degree of freedom is given by K minus 1. So we have our K here, which is 4. 4 minus 1, we get a 3. To get the mean, we divide 3 into 30, that's a 10. And degree of freedom for the within, it is N minus K. So our N is what? 12. 12 minus 4, what do we get? 8. So we get 8. The mean, divide 8 into 160, we get a 20. Then the degree of freedom for the total is N minus 1. Our N is clearly 11. 11 is 12. 12 minus 1 is 11. Alternatively, just add 3 plus 8, which is 11. So you'll be given the total, you'll be given the between. Then the F calculated is when you divide the 20, which is the mean square within, into the mean square between. So 20 into 10, we're going to get 0.5. And then to read the F tabulated, if you're given percentage like 5%, you use the degree of freedom to read this degree of freedom here at the coordinates 3,8. So when you're going to read in the F table, you need to check on what has been given there. So what is the reading under 3,8? Do we have the tables there?
Hi, Collins.
Yes, please.
Kindly explain again on the 3.6.
3.6. I was saying you're given the following parameters. From this table, the job of the degree of freedom is to help you read the reading of the table. So this is 3,8, not 6. this coordinate 3,8 is what you're going to use to read the table. It comes from the between and the within. So you're going to read in the F table, coming from on top, it is a 3 since a treatment. Coming from the horizontal, so within, which is what, 8. And that is a percentage of the table, a 5% table. So where they meet. So you go into this table, make sure that it is 5%. So 3,8 is 4.01. That's a reading which we're going to get 4.01. So you're going to compare. If this one is greater, we reject. If this one is smaller, we fail to reject. So since our F calculated is smaller than this, we're going to do what? Fail to reject. To fail to reject is simply to do what? To accept. So that is how our balancing of the table will be. So we're going to try another table. Before we go there, are we together? The table. So tables are the first thing that I want you to acquaint yourselves with. Because once you know how the data is supposed to be arranged, then you are going to have an idea. So in this case, the populations have been transposed, they can't be. So here we have 1, 2, and 3. So here our populations K is equal to 3. These are populations. The total number of observations 1, 2, 3, 4, 5, 6, 7. N is 7. And you'll be given maybe sum of square total. Sum of square between. Sum of square between, maybe you're given a 20. Then sum of square total, you're given 100. So to balance up this one, at 1%, just needs to memorize. This is the easiest topic. The sources, how many sources do we have? We have between, within, and total. So here, sum of square, we have sum of square what? Between, sum of square within, sum of square total. In this case, between, we're going to have what? Given between is what? 20. Total, we're given what? 100. And how do we get sum of square within? It's a difference, which is 8. Degree of freedom is K minus 1. We're dealing with between. So K is the number of what? Treatments. So 3 minus 1, 2. And this is N minus K. So 7 minus 4 minus 3 is 4. And you total up, you get a 6. The mean of squares. Mean of squares here, just dividing this answer in there. So 2 into 20, 10. 4 into 20, into 80, 20. F calculated, now going to divide 20 into 10, 0.5. The next one is we read from the table. What coordinates are we using? 2, 4. But what percentage have we been given? 1%. So the percentage is the title of the table. So you go and check. This is 5%, so no. This continued 5%, no. 1%, yes. So what were the coordinates? The coordinates were 2, 4. So check under 2, 4. 2 coming on top, then 4 there, that's 18. So we're going to put 18 here. If tabulated, 18. So if this calculated is greater than that, we reject. If it's smaller, we accept. So since this is smaller, we accept the HO. Now, sometimes you'll be given figures to calculate A, B, C. 1, 1, 2, 3, 1, 2, 2, 2, 1. So here we sum up. The total here is 4. This is the 2. Then the total up here, we're going to get what? 6. Total up here, we're going to get a 5. The sum total here will be what? 15. Then we go to the end. How many are they in here? 3. How many are they here? 3. How many are they here? 3. And the capital N here is what? 9. You square each total there. 1 squared plus 1 squared, 2. 2 squared plus 2. That is 4 plus 2, which is 6. And this is 9 plus 1, 10. 10 plus 4, 14. That is 4 plus 4, 8. 8 plus 1, 9. Then we sum total here to get what? 29. Are we following on how we are getting these totals? So using the formula, sum of square total is simply summation of x squared minus summation of x to the power 2.
Wait, Mr. Collins. How are you squaring those numbers?
It's
You
individual.
add them first and then square.
No. I think I've already explained. You square it. This is 9 plus 1, 10, plus 14, plus 4, 14. Don't make a mistake of squaring these ones here.
You square before you add. The
Square,
opposite, to square before you add.
yes, to square before you add. Yeah. I like that language. You square before you add. Okay, so this is sum of square total, which is given by summation of x squared minus summation of x to the power 2 over n. Okay, so what do we get? 29 minus 15 squared over 9, quickly.
$25.
Can be 20. The final answer is 25. What is 15 squared over 9?
It's 25, the final answer.
25. Okay. Confirm? So meaning this is 4. 225
Wait.
divided by 9.
We are subtracting 29, isn't it?
Yes.
I
29
did.
minus 25 is 4. You're correct.
This is 4. Are you sure? 15 times 15 over 9. What do you get?
25.
25.
25. So this is 25. 29 minus 25.
25, which gives you 4.
Okay. So here, it's a treatment that we're doing now here. Each treatment total. 4 squared divided by 3 plus 6 squared divided by 3 plus 5 squared divided by 3 minus 15 squared divided by 9. What do we get? So what are you getting here? If you have the same denominator, let's say 4 squared plus 6 squared plus 5 squared.
21.67.
The final answer?
Final answer is 21.67 unless I've done it wrongly.
Give me what is 4 squared plus 6 squared plus 5 squared? This is
77.
77. 77 over 3.
Gives you 25.67.
25.67.
Minus 4.
I'm finding 0.667.
Minus 25.
Exactly.
Minus 25, not minus.
67.
0.6.
0.67, yeah.
Okay. So this is a sum of square block. Now let's balance this. Everything has now been done. So what is the sum of square total? 4. Sum of square block, we just found 0. What? 67. Then what was our number of treatments? Our K. And what was our N? So number of treatments here 3. Those are the populations. And our N was what? 15. N was 9. 9 and 3. So let's balance up this. So source, we have 3 sources. What are the sources? Between,
Within and total.
and total. So what is the sum of square between? Here, 0.67.
0.67.
The total, 4.
4.
The within is the difference. What is the difference?
It's
Within
giving me
3.33.
3.33, correct?
Mm.
That is 4 minus 0.67. Degree of freedom for the between is K minus 1. 3 minus 1 is what? 2. The degree of freedom for the within, N minus K. 9 minus 3 is what? 6. Then you total up to get 8. How do we get the mean of squares? We divide the degree of freedom into the sum of squares. So let's divide 2 in there and 6 in there.
For between, it's 0.335.
0.335.
0.335. We
In
divide.
class, baby.
So you divide this. Just put the division.
0.55.
0.5.
0.55. Then to get the F calculated, you divide these two here. Let's put the division there and put this. So this one divided by that.
Zero 0.603. 0.604.
3. Then at 5%, what are the coordinates? Two, 6. The coordinates come always from the degree of freedom. So under 5%,
Collins, me, I'm for when you divide 0.55 divided by how are we doing? Which one is
dividing
the
this
denominator
divided by that.
into this?
0.33 over 0. Not the other way around.
Okay, I was doing the other way around.
Right. Then the F calculated is 2.6. So make sure it's a 5% stable. So 2.6. 2.6. That is 5.14. 5.14. What is our decision? To reject or to fail to reject? So since this one is smaller than that, we fail to reject. Okay. Then you can conduct a test, which simply says, since there are 3 means, or there are 3 populations, so step 1, you say for HO, simply states that mu1 is equal to mu2 is equal to mu3. There are three means there. mu1 is equal to mu2 is equal to mu3. All right. So the first one I say mean 1 is equal to mean 2 is equal to mean 3. And here you say at least one is different because there are three means there. All right. If there are four means, you do the same. Step 2, set the level of significance. They gave us 5%. Step 4, state the what? The rejection rule. We checked under what? 5%, 2,6. So this will be very easy to find after you do the table. So the 2,6, we found it from the table, which was what? What was our reading? 2,6. We went under 2 and 6, 5.14. That is why we found our 5.14. So this 5.14 is what comes here in the table. And the bell-shaped. Then step 4, we calculate the F calculated, which we found as what? 0.6. In conclusion, we fail to reject HO. Whenever we fail to reject HO, it means there's no statistical difference. All answers that fall within is here it's fail to reject. We don't have evidence to reject. Here, we reject. It's a rejection region. So if your answer is inside here, it means there's no statistical difference. And if you reject, there's what? A statistical difference. So here, reject HO. Now with that background, I can now take you to the tutorial sheet, activity 4. You need to understand all the activities for you to be ready for the exam. So the question that you've seen here is just a type of how the exam questions will come. So what's the first thing you do? If you understood me very well.
You total up every
Up.
column.
So summation of x and n and summation of x squared. Are you able to total up for me? So to conduct, this is a full 25 mark question, which should be enjoyable.
That is very true.
Yeah. Please remember me when this one comes. Just smile. Mr. Collins said it will come. So when you do this, it's
The first total is 30,
30, then
27, 36.
The total of totals here is what?
$93.
93.
93.
Okay. So then n, how many are there in here? 1, 2,
6.
3, 4, 5, 6, 7,
6.
6, 6, 6. The total here is what? 18.
Mm.
And the squares, what's the square total here?
One 54,
154.
123,
123.
218.
218. And the total of totals here is what?
$495.
495. What else can we get from this table? Our K and our N. What is our K? 3.
3.
Our N? 18. Then now we can calculate the sum of square total. Who remember sum of square total?
Colin, sorry to take you back. Sorry, I'm just a bit lost on how you got the 3.
The number of populations 1, 2, 3 is K.
Okay. That's the number of population. Okay.
Then the N is the total number of observations. So count them one by one, the 18. Is that clear? Okay, any other questions at this point? No, Siku?
Mr. Collins.
Yep. All right, so now we now go to finding the sum of square total. What's the form of sum of square total? Mali? Am I audible?
Yes.
Yes, just copying
Yes.
the vacancy.
Okay, so we're going to calculate the sum of square total. That is sum of x squared, sum of x all squared, then that over that. So here we're going to have 93 squared divided by 18. What do we get as the final answer there? 3 squared divided by 18. Then from there, what are we getting?
14.5.
14.5. We agree? And for the sum of square between, we get the between treatments individually. 30 squared over 6 plus the next total is what? And 7 squared over 6 plus the next total is what? 36 squared over 6 minus 93 squared over 18. What do we get?
Confused a bit here.
Sum of square between, we're just getting the total here. This squared over that plus this squared over that plus so each treatment. The variations in each treatment. That's what's called sum of square between the treatment. So 30 squared over 6, 27 squared over 6, 36 squared over 6 minus the correction term, which is 93 squared over 18, just as they are appearing. That's the computation we're doing here. What are you getting?
It's giving me 7 as a final answer.
Yes, 7. So with these key parameters, can you set up an Anova table?
Yes.
All right, Maggie,
Yes.
can you lead us through? So what we have, sum of square total was what? 14.5.
14.5.
Sum of square between was what?
7.
And our k was what?
3.
And our
Three.
n was what?
18.
13.
Okay. Are we ready to go?
Yes.
So the three sources of
Yes.
duration we have are number one,
Between,
between,
within, total.
so we can start. Sum of square between is what?
7.
And total,
It's
14.5.
14.5.
great. So how do we get the within?
The
You
difference
subtract.
Excellent.
It's 7.5.
6.5.
5.
That's 7.5. Sorry.
I love the way you're answering. It seems like you guys are ready for the test. Degree of freedom, K minus,
K minus 1,
K is what?
2. Oh,
Is
3.
2.
3 minus 1.
3
3.
minus
3.
1.
Then here, n minus k, our n is
N
what?
minus K.
Okay,
3
which is
minus
18 minus
18. 18 minus 3.
Which is what?
15.
15. Then the total here, just
Mm.
up, just add or subtract 1 from the total. 18 minus 1 should also be the same, 17. Are we together this far?
Yes.
Then we go to the mean of squares. Leah, what do we do to get the mean of squares?
You divide the SS between and degree of freedom,
So cool, kafika division hapa na hapa.
which is 3.5.
So this is 3.5. Then here,
is 0.2.
0.5.
0.5.
0.5.
Correct. Then here the f calculated. What do we do? And now
You
divide.
divide 3.5 divided by 0.5.
What do we get?
7.
Good. Then the f tabulated. Which are the coordinates?
7,
Two.
2,
15. So kindly help me. I'll beam the table and you give me the reading precisely. Can you do that?
3.68.
So what are the coordinates?
3.68.
The coordinates. What are the coordinates?
7,15.
2 comma what? 15.
15.
So 2 here, right? And the what? 15 there. So what do we get?
3.68.
3.68. Do we all agree?
Yes.
So here put 3.68. What is our decision? What is our decision? When do we reject? Only when this one is greater. When it's greater, we reject. When it's smaller, we accept. So what are we going to do between these two?
We failed to reject.
We accept.
You guys,
We reject. We reject.
when this is greater, you're starting on a very good note. Your CEO is going very well. This is very important. When it's greater, 7 against 3.6, what is our conclusion?
We reject.
Reject.
We reject.
Since 7 is greater than 3.6.
7 is greater than this. Yes. Whenever you're rejecting, there's a statistical significance that is happening. Then clearly you can conduct a hypothesis test. Our mu1, what does it mean? Just say mu1 is equal to what? Mu2 is equal to mu3. Why? Because we have 3 Ks there. Then here you say at least one is what? Different. Step 2, the degree of freedom.
Oh, Collins, just come again. I'm sorry to take you backwards. Yes.
This is it's also a hypothesis. So step 1 is say mu1 is equal to mu2 is equal to mu3 because there are 3 what? Populations. If there were 4, mu1 is equal to mu up to 4. Then here just say at least one is different. Number 2, state the level of significance. SL is what? 5%. Number 3, state the what? The decision rule. we now show the rejection rule. We're going to reject if F calculated is greater than what we found in the table, which is 3.68. So here is reject HO when if our F calculated, not Z, it's F calculated is greater than what? 3.68. Everything I've done, I just extended the table for you so that you don't lose your marks. It's not most students lose marks here because they don't know how to make a decision. Then step 4, we make a decision. What's our decision? Reject HO. Chapwa, meaning there's what? There's a statistical difference. So now let's see the solutions that God did. Mine are very systematic, though what he did is correct, of course, but the order was not really impressive. I just need you to appreciate my order.
There to understand.
So if
Yeah, doc solutions are very difficult to understand.
the sum of,
Because he's ever fast and you don't ask a question. That's the problem with him.
yeah, so the sum of square block, we found 7, you see? Sum of square total, we also found 7.5 within, and the total should be a 14 point what? 14.5. Where is it? I can't even see where his total is. Sum of square total 14.5. Okay, we found this. Then when you put them in the table, it will give you the F calculated, which is 7. Then the F calculated, he needed to show you where you found the 3.68, which I've shown you where it's coming from. Since F calculated, which is 7, is greater than 3.68, we're going to reject HO and conclude that there's statistical difference. So I've done this jargon in a very systematic manner that you're able to follow and enjoy. You can see, right? So step by step, everything is as was done there. So please take your time to go through this. Unless there are any questions, ask now or forever hold your peace.
Mr. Collins, just a request if you can share a video. Some of us are not aware it's going to be class, so we saw it late.
Okay.
Hi, Collins. Collins, just remind me again, I was quite lost on the degree of freedom. How did you find the 215?
The 215, this K minus 1. So 3 minus 1.
Oh, sorry. Okay, yes.
Then
K
A
minus 1, yeah.
So everything comes from the what? From the table format. All right. So is that clear?
Yes, thanks.
Collins,
Yes, please.
Collins, yeah, is it okay to master two formulas where there's a sum of square
Yes, it's okay. At this point,
instead of having 3?
I will encourage you
Hello?
to go for what is easier for you, as long as you arrive at the same answer. All right. Of course, my formulas are the same.
Okay.
There's no difference whatsoever. It's just they're systematic. There's nothing different. But yeah, it's okay.